Did it start recording?
Yes.
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 Yes. All right. Okay. Now, for this problem here, as I said, what you need to do, you should take to solve this problem 1.5615 gram AgCl. You multiply by, what's the mass of chlorine?
35.45.
And what's the mass of chlorine plus, what's the mass of Ag?
It is 107.87.
Plus 35.44. Okay. This way you have the answer. What's the answer in this case?
0.2473.
Anybody got the same answer also?
Yes, Mr. Me.
Sure. Okay. What I did here, I divide by the molar mass to make it mole, and then 1 to 1 mole, and multiplied by the mass of chlorine, which is 1 mole, and I got the amount of gram Cl. Now, next step is just to write 0.2473 divided by 0.8633 times 100, and the answer should be, give me the answer.
44.74.
And then all what I want you to do is just to write this number without any percentage or any other calculations or units or anything. That's how we're going to do the quizzes, always like this. All right? Yes.
I have another result.
It's a 28.65.
It's 44.73, so this is the correct answer. It's 44.73 or 44.73, the correct answer. So if you have another result, this means you have a problem in calculation. You have to know what you're doing.
No, the result of the written in here is 28.
No, doctor, it is 0.38.
Yes, Dr. Migo, me too. I get
Yes.
0.3.
I'm depending on you to do. Tell me. Let me do the problem.
The first one, Doctor.
It's, yeah, of course, there is something wrong. Somebody gave me a wrong number. Now I did it. It is 0.3862. All right, and now is also here wrong. The 862. The right answer is 44.74 is correct. How come we have a wrong number and correct answer? Anyway, do you know how to do things now?
Because
No.
we memorized it, Doctor, from the last lecture.
That's the problem. Okay, I want you to know what you're doing, not to memorize numbers. Okay, now, the other thing is, the first question was, as I said, whatever concentration you have to do, multiply it by 5, every time you multiply it by 5 and then divide by, it's actually, you take the same number, whatever is given to you, what was the number? 1.35, let's assume, 1.35 multiplied by 5 over 100 times 5 over 100 times 5 over 100 times 5 over 100 times 5 over 100. That's the answer. If it's 1.35. Is this clear? And then whatever
Yes.
you have the result, I think the result was 4.22.
4.22 times 7.
That's what I want you to write. 4.22 E minus 7. E minus 7, don't forget. And alhamdulillah, I saw the result. Many get the correct answer, but unfortunately, also many did wrong. Either take 2 points or 0 points. There is one person got 0, I think, which is unfortunate. Anyway, as I said, this quiz is not counted. Don't worry about it. I will completely delete it. But expect this quiz. Every time we have homework or something new, I may tell you to do this short. It's not part of the quizzes, it's part of the homework, and expect it next time. Yalla, let's finish with chapter 4. Let's go to chapter 10.
So
Doctor.
the next will be marked, right?
What again?
The next one will be marked.
March?
It will be graded.
Yeah, it will be marked, yes, of course. Next quiz, it will be part of the homework and it will be graded as part of the homework.
Doctor,
Yes,
if I wrote 44.70, would that have been wrong?
I don't know, it will not be wrong.
Okay.
Because it will be within the error. I put the error up till about 0.5. So if you write 0.0, if you write what was the answer for
44.7374.
7.3? If you write 7.9, it will be wrong. If it's 7.3.
Okay.
But if it's 7.6 or 7.7, it's still right. It will be correct.
Also, the margin of error is 0.05.
I put it this time 0. I will change it from time to time, but this time I put it as 0.05.
Okay, thank you, Doctor.
Okay. All right. Let's continue our discussion with chapter 10. All right. Good. Right. We are here. Okay. What is this law?
Ideal gas law.
What's the name?
Ideal gas law.
Ideal. You must memorize this name. Ideal gas law. Ideal gas law. And I also told you 1 mole of gas at STP give you how many liters?
22.4.
22.41. I want you to memorize this number. Liter. I want you to memorize this number. What's STP?
Standard temperature on gas.
Exactly. What is it in numbers?
0 Celsius and 1 atm.
Exactly. You must know this as well. Very good. All right. Good. Next. I also told you that, yes, this is the number that I want you to memorize. Keep this in mind and memorize it. Very good. Next, we said that PV equal to N R T. What is N?
Number of
The number
moles.
of moles.
Number of moles.
It is mass over what?
Molar mass.
Molar mass.
Over molar mass. So I want you now, you do it, replace N instead of and tell me what's the value, what's the molar mass? How to find molar mass of any gas equal to what?
Mass RP over PV.
Mass what? RT
over PV.
over PV, or I'll put the P here and put the V here deliberately. VP or PV, it doesn't matter. Is this clear? You have to do, I don't want you to memorize this equation. I want you to memorize this equation, and you should be able to find how to find the molar mass. How about what's mass over V?
Density.
D.
So I can say that M is equal to what? Density
D. RT.
over
Volume of
Over P.
over only P.
all right.
Mass over volume is density. I change it to density. So as a result, what's the density of a gas?
MP over RT.
Molar mass times P divided by RT. Is this clear?
Yes.
You have to know all these equations, even though, as I said, don't memorize them, but be ready to derive them. Don't forget, this is the most important thing. We know that N is equal to mass over molar mass. I can put the N and find the molar mass easily. Good. Next, calculate the volume of 1 mole of gas at 25 degrees C. This we did last time. I'm not going to go over it one more time. Let's do this one. Carbon dioxide, which is CO2, is effective fire extinguisher. Do you know the fire extinguisher at our homes? Almost.
Yes.
I use CO2. Okay. The density, why they use CO2? Because the density of CO2 is higher than the density of the air. If the density of the CO2 is higher than the density of air, what will happen? CO2 will come where?
Beneath the air.
Down. And the air will go up. And as a result, the fire will not find oxygen and it will stop. Is this clear?
Yes.
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 Density is greater than that of air, so CO2 can smoother the flame by depriving them from oxygen. Air has a density of approximately, the air is approximately 1.2 gram per liter. All right, calculate the density of CO2 gas. Of course, before we do the problem, what do you expect the density? Is it going to be greater than 1.2 or less than 1.2?
Greater than.
Okay, how? Then again, as I said, PV equal to nRT, which is mass over molar mass RT. Then what's density? From this, what's density?
MP over TR.
RT over P.
MP over RT. Very good. All right.
Victor capital M.
Oh, yes. I'm sorry. Yes, I know this. Yes, it's not mass. It is. Okay, go ahead, calculate the density.
Doctor, how density is molar mass with P?
Density.
It is 1.80.
What you should do, multiply the mass. What's the mass of CO2?
44.01.
What's the pressure?
1 atmosphere.
1. And what's the R?
0.082.
0.083.
T?
298.
Plus 15. That's right, right way. Yes, okay. So what's T? 298.15. And you should have the answer. What's the answer? Quickly.
1.8.
1.8 gram per liter. How easy is this?
Easy. Easy.
So
So
easy.
Very
So,
easy.
now, we have a chemical reaction. As I said, we can relate things not only by mole, but if we have everything is gas at the same. Okay, so if you have this equation, read this equation. 2CO gas plus O2 gas goes to 2 CO2 gas. Is this balanced?
yes.
Okay. If we have equation like this, how can we relate things? By what? By mole. How
By
can
mole.
you relate by mole?
V over N equals V over N.
No. I mean, how can you compare things by mole? You should say 2 mole CO with 1 mole O2 give you what?
2 moles.
CO2.
Almost.
CO2. So if I give you 5 grams O2, then how can you find how many grams will be produced?
Multiply by 2.
First, no,
One.
wrong.
Oh, yeah.
Limiting reactant.
Change it what?
Mole for
Change it to mole.
First, change it to mole. Then you should say that this is 32.00 gram O2 is 1 mole O2. And then I know that each 1 mole O2 give me how many moles CO2?
2.
2 mole CO2. And I know that each 1 mole CO2 give me how many grams? 44.01 gram CO2. Now give me an answer. I want everybody to work and think and give me an answer, final answer.
13.75.
Who got this answer?
Same, 13.
Yeah, as I said, I'm taking your number, so many who should do it, and you should confirm that the number is right. Okay, so if you have things, you can relate things by gram, by mole, and then you can relate them. Can you relate them by other means? Yes. For gases at same P and T, you should not change the temperature or the pressure. Then I can say 2 liter CO react with 1 liter O2 to give me 2 liter CO2. Is this clear? So if I have, in this equation, if I have 17 liter O2, how many liters CO2 I'm going to produce at the same temperature and pressure?
34.
32.
34.
Oh, you
34.
should write at the top here, 2 liter CO2 react with 1 liter O2. This goes with this, and you have the answer as 34 liter CO2. So,
Doctor,
yes,
don't we have to find the limiting reactant first?
oh, I did not give you the other one. Of course, yes, good point. If I have, again, good point. Let's say 17 liter CO and 17 liter O2, then how many liters CO2 I'm going to produce?
First, you must find the reactant.
34. 34.
Sure.
17.
Yes.
17, yeah.
17. Why?
CO is the limiting reactant, and 2 to
In this
2.
case, I need only 8.5 of this one. I'm not going to use 17, this like here. I'm going to use only 8.5. Why? Because there's a limiting reactant. Of course, you have to be careful with the limiting reactant. Is this clear? Good. Okay. Let's solve this problem. Sodium peroxide, this is sodium peroxide, is used to remove carbon dioxide from and add oxygen to the air supply. So it reacts with CO2 and give you oxygen, which is good. We want sometimes to produce O2. This is used in spacecrafts. You know what spacecrafts? المركبة الفضائية. Yes. All right. So we have this reaction. It works by reacting with CO2 in the air to produce sodium carbonate like this reaction. What volume in liter of CO2 at STP will react with 1 kilogram of Na2O2? So I have 1 kilogram of Na2O2. And what do I'm looking for? What am I looking for?
The volume of CO2.
Volume of CO2 at what?
Liter. At STP.
At
Standard
STP.
temperature pressure.
Okay. What are you going to do? How to solve this problem?
2 liter Na2O2 gives 2 liters CO2. And you change the 1 kilogram to mole, 2 liters.
Big problem. Do you agree with your friend?
No, because in A2O2 is solid.
It's not gas. We can't do liters. Is this clear? You have to do here. Can I use liters?
No.
No. I
No.
can use only mole. So I know from the equation what's the information that I have? 2 mole Na2O2 react with 2 mole CO2 to give me 2 mole of this one and 2 mole of this one. I don't want. I want to know how many liters of CO2 will react with this one. What should you do?
Convert it to molar.
Kilogram to the mole.
It's the first thing I should do. Actually, I will just simply, instead of 1 kilogram, I will write 1,000 gram in A2O2. What should I write at the top? 1 mole in A2O2. How about the bottom?
77.98.
77.8 gram in A2O2. Good. This grams goes with this gram. Now, the mole. How many moles will be with what mole? 2 moles.
12.82.
What's 12?
I calculate the
Yeah, you have the answer. No, wait, we do that. Yeah, okay, good. But no, at this time, I want to get rid also of 2 mole Na2O2 with how many moles of CO2 is needed to react to this?
2 moles.
Also 2.
Moles CO2. Get rid of the mole with the mole. And now, this is at STP. So how can I change it to liter? 1 mole CO2, give me what?
22.4.
That's it. Now give me the final answer.
$287.25.
287 point what?
38.
25.
38.
38.
38.
I got
287
Yeah, me
point-
too. 38.
Is this clear?
0.42.
Okay. Okay, good. Next. Also, let's very quickly go back, erase here. I want to erase here and erase here, and I want to stop here. And I'll tell you what's the answer in here. Only after this step. Give me the answer.
12.82.
12.82.
82. Who got the same answer?
Me.
Me.
All.
I got
Then I will apply PV equal to nRT. Can I do that?
Yes.
Yes.
Yes, you can.
For liter, so I want volume. Volume is equal to what? Number of moles, which is 12.82 times what?
Constant 0.0821.
Times temperature. What is it?
273.
0.15.
Divide by pressure. What's pressure?
1.
Give me the
One.
answer quickly. It should be the same answer.
Yes, it's the same answer. 287.58.
How easy? Good.
Easy.
Next. If I know that PV equal to nRT. I want what's the relation between N and P. N is equal to what? N equal to P.
PV over RT.
PV over RT, but I want to separate the P here and make it PV over RT like this. And I want to keep everything constant, volume, temperature, and of course R. And I want to take the change in the amount. The change, this way, the change in the amount will be the change of the pressure. Or we can calculate the change of pressure by this method. As I said, PV equal to nRT, or N is equal to what? PV over RT, and then I will keep this as is. I will take the change in this one. All right, good. Let's solve this problem. We will use this equation. Don't forget. We will use this equation to solve this problem. Go ahead. Another air purification method is to enclose space involved in the scrubbers. Something to clean water, to clean air, okay, containing aqueous lithium hydroxide. This is lithium hydroxide, which react with carbon dioxide to produce lithium carbonate and water. Consider the air supply in this is used in submarine. What's submarine?
غواصة.
Okay, with a total volume. This is the total volume. So you have what? What's this? 2.5 times 10 to the power 5. What is this?
CO2.
V. Volume. This is the volume. Okay, good. The pressure is 0.9970 atmosphere, and the temperature is 25. If the pressure in the submarine drops, this is P1 and this is P2. If the pressure of the submarine dropped to 0.9891 atm as a result of carbon dioxide being consumed. Aqueous lithium hydroxide scrubber, how many moles CO2 are consumed? Okay. What do you have here? You have the volume. What's the law that you're going to use?
Ideal gas.
Delta N equal to what? Delta P.
P
For RT.
RT. And the P we subtract the first one to the second one.
What do you have here? What is the volume?
2.5 multiplied by 10 to the power 5.
Okay, what's the temperature?
298.15.
298, yes, 298.15. R is 0.0821, don't forget it. 0.0821. What's delta P?
We'll subtract
0.9891 minus 997.
P1 minus P2. Give me an answer.
$80.68.
Yes, that's correct.
No.
Yeah, 80.68, yes.
0.0.
0.0079.
Yes. Subtract them, it should be like this. 0.0079. All right. What's delta N in this case? Give me the value for delta N.
80.68.
80.68. Who got the same answer?
Me.
So how much has been consumed of CO2? How much of CO2 has been consumed? 80.68 liters. I hope this is the correct answer. 81, yes. The answer is 81. So yes, this is the correct answer. Good. Do you know how to do this also? Is it easy?
Yes.
Okay. Yes. The airbag, do you know the airbag that we use in our cars?
Yes.
The airbag is actually will be inflated when collision happen. Okay, highly exothermic decomposition of sodium azide. This is called sodium azide. When it decomposes, it will give you sodium solid plus NO2 gas. A typical driver side air bag contains 50 grams. So this one is, we have 50 grams in 3. Determine the volume of O2 gas, N2 gas that would be generated by the combustion of 50 grams of sodium at 85 degrees C. So from the equation, how can I relate things?
Convert gram to mole.
I can say that 2 mole Na2N3, Na3, sorry, there's no 2, Na3 react with what? Or give what?
3 and 2.
2 mole
A and
3 mole
3 mole N2. Can I use a letter instead of mole?
No, solid.
Why not? Because there is solid, exactly. So if I have 50 grams of NaN3, how many first mole of N2 will be produced? How many moles? What should you do?
Divide by the molar mass.
Okay, go ahead. Find the molar mass and give it to me quickly.
65.02.
What should I write at the top?
One more.
N3. Good. Then, what should I write here to find the number of moles?
3 mole of N2 over 2 mole.
N2 over 2 moles in N3, and you have the answer. Give me answer.
1.15.
1.15 mole N2. I hope everybody's checking for the others. Now,
Yes, it's correct.
Yes, it's correct.
tell me what's the volume. What is it?
Multiply by 22.41.
No, wrong. Why is wrong to say multiply by 22.1?
Solids.
Because it's not
It is not
STP.
STP.
Is this STP?
No.
Okay, so no, you cannot use 22.4. You have to do it this way. What should I write here? 1.15 times 0.0821 times, what is it? Add 273 plus 85.
358.
358.15. And give me quickly the answer.
33.
33.9.
92.
Exactly. Very good. All right.
Doctor,
Yes.
50 Celsius isn't at STB, right? 15 Celsius isn't at STB, right?
No. Zero
Only
Celsius
zero.
STP.
Okay.
Zero
Doctor.
Celsius. Okay, next.
Doctor,
Yes.
for this problem, if it said it was an STP, could we have used 22.4 liters? Or because it's solids, we can't?
No, you have to change it then. I did not do that. Okay. What does it say? Where is it?
If it said it was STP, can we use 22.4 liters?
Sure. Of course, yes. If it says STP, then yes, the temperature and the pressure is 1 and 0. Then you can use 22.4 liter. Yes.
Even though they're solids, is that okay?
Yeah, but I'm talking about the gas only. If if this gas at STP, then to find the volume, I multiply by 22.4. Okay?
Okay, thank you, Doc.
Dalton law. Next, Dalton law. Let's assume I have a box. The volume of this box is V. I'll call it V, only V. All right? And temperature is T. And of course, it has the same volume and temperature. Okay, and let's assume that I have this pressure is P1. The pressure for this room, there is gas here, I'll call it X gas, and the pressure of the gas is P1. Clear? Good. I have another room here, which is exactly the same volume. So I'm going to write it as V, and the same temperature also. All right. But it has another gas, which is this gas, and the pressure of this gas, P2. Clear? I took these two boxes or I took the gas from P2 here and added to this box. So we have the same box, same volume, same temperature, but now I have the X is mixed with the O. That's exactly now the same. All right. Now let me ask you, what's the pressure of the new box?
Sum of P1 P2.
P1 plus P2.
P1 plus P2. Exactly. Why are you saying this?
Because they have the same volume and temperature.
Exactly. Because it's the same volume and temperature and same amount. See, I tried deliberately here. How many X's do I have in this box?
7.
7. And here? In this box?
10.
No. Well, X's. 7. I deliberately did put it 7. So the pressure of X in this box is P1, regardless of what's the... Now, how many circles do I have here?
10.
10. And how many circles did I put here?
Also 10.
Also 10. And it's the same volume and temperature. That's why the pressure is P2. Okay? So the pressure in the gas is actually the addition of the pressure of each one of them. This is called Dalton law. So pressure, total pressure, P total, is equal to what? Summation of pressure of individual component. That's called Dalton law. How easy?
Very easy.
So easy.
Now we know that. So this is Dalton law. Okay. So this is Dalton law, as I said. And it's very simple, or PT equal to P1 plus P2 plus P3 plus whatever gases you have, whatever. And that's why summation P1. Okay. A 1 liter vessel, so the volume is changed, contain 0.215 mole N2 and 0.0118 mole H2 gas at 25 degrees C. Determine the partial pressure of N2. So what's P of N2? What are you going to do?
Use N of N2.
Use what?
The number of moles of N2.
Which is what? Give me. How are we going to get the pressure?
Ideal gas law.
Ideal gas law. How are you going? What should I write then?
BB equals nRT.
0.215 times what?
0.0821.
21 times 298.
298.65.
65 divided by
1 liter.
1 liter.
Give me an answer quickly. Yes.
5.27.
Exactly. What's the pressure of H2?
0.0118.
0.0118
multiplied by 0.0821
2821 times
98.
0.65 divided by 1, which is equal to what? Give me an answer.
0.29.
Good. What's the P total?
The sum of them.
Sum of them, which is going to be what?
5.56.
How easy?
Super easy.
Super easy. Very good. Now, I want you to calculate the pressure from the first time. P total. Can you do it?
Yes, add N of N2 and N of H2.
5 plus 0.0118 times RT over V. And you'll get the same answer. Is this clear?
Yes.
Very good. Now, let me talk about another thing. Mole fraction. What's mole fraction? Mole fraction is the moles of one component over the total mole. Total mole. All right? So I want you to memorize this letter, which is X, but it's slightly bent like this. What's this letter called?
Mole fraction.
Mole fraction. And what is it equal to?
Mole of the component of mole of total.
N of the component in I over N total. Very good. Let's go to our problem. Can you find what's the mole fraction of N2?
Yes.
It should be 0.215 over
What? 2.15
over total moles.
What is it?
Over 0.215 plus 0.0118.
Give me an answer. Yes.
The answer is 0.947.
0.118.
The answer is 0.95.
0.95. All right. Clear? Okay. Again, let's go back. This is the total pressure. Now, I want you to tell me what's the P of N2 divided by P total.
0.95.
This is P2, Pn2, and this is P total. Give me what's the answer.
0.95.
Exactly, 0.95. Do you see any similarity?
Yes.
Yeah, they are the same.
From this one, what can we say? That the mole fraction equal to what? Ni over total, or equal to what?
Pi over P total.
PI over total.
Or P total. You have to know this law very well. Again, this is the Dalton law again. Dalton law. Is this clear?
Yes.
Yes.
Very good. Now, if I know the P total, okay, what's the relation between Pi equal to what compared to P total? Right?
Right.
Pi equal to mole fraction times P total. All of this are other ways of doing Dalton law. So Pi is equal to what? Xi times P total. I hope this is clear. You have to know all of these things. They are very easy, but don't forget them. Okay, calculate the mole fraction of NO gas in 10-liter gas cylinder at room temperature zone that contain 6.022 mole N2, in which the total pressure is 14.75. So we have here P total, and we have N of N2, not everything, not N total. Okay, but we want to calculate mole fraction. Mole fraction, can we do that?
Yes.
Yes.
From P total, what can we calculate?
N total.
N total equal to what?
P total times V over RT.
Exactly. Go ahead and give me what's P total. Give me answer.
$6.025.
Two, what? No, wrong.
6 after rounded.
9 actually.
9, yes.
There we go. 6.029. You have the PT, this is PT, and you have the volume, 10 liters, and you have R, of course, constant, and temperature is 25, change it to Kelvin. And this is the N total. Now, what's the mole fraction?
$6.022 over N total.
You may answer. Is it right?
Doctor isn't asking about NO, not N2.
Oh, okay. Sorry. Yeah, just a second.
So it should be
Yeah.
N total minus.
Yeah. Now, what's the small fraction of what? This is the mole fraction of N2. Give me answer here.
Should be 0.007.
99. No. Divide 6.022 divided by 6.029.
But aren't we supposed to find it for NO?
Just a second. We'll do it. Divide this number by this number. Do you have this number?
Yes, doctor.
Okay. What is mole fraction for NO?
0.0001.
Minus 0.999. Because it's always the total mole fraction must be 1 of all the gases. And so what's the mole fraction of NO? It is 0.001. Is this clear?
Doctor,
It's
Yes.
all one.
But
can
again,
we find it the normal way, doctor? Finding the moles of NO by the normal way, by using the ideal gas law?
of course, yes, of course. But how are you going to calculate the number of moles of NO?
N equal PV over RT.
Yeah, but you don't have a P, you have P total.
Aha, okay. I need to learn this first.
Of course, what you can do, you can calculate the pressure of N2, all right, which everything you have. You have N and V, and R, everything is there, and T. So you can calculate Pn. Then what will be the pressure of NO? What is it going to be? P total minus Pn2. And then you can take this one and apply PV equal to nRT to calculate it. To calculate the number of moles. All right. Okay, with this, we'll stop here. And let's, as usual, take the attendance. Okay. The attendance form is now open. Okay, go ahead, do the attendance, and you can leave right away. Thank you.
Excuse me, doctor. Is there any news about the midterm?
لا والله لسه ما في أي نيوز.
ولا تاريخ دكتور؟
لا والله مرة ما عندي، أنا ما عندي، ما أدري إذا حد عنده. ما قال لكم المدير في اللقاء شيء؟
لا والله ما أعطانا إلا تلميحات يعني، بس أنا أي تاريخ يعني توقعنا عشان أبدأ أرتب ذاكرتي.
والله يؤسفني أقول لك I don't know. يؤسفني جدا بس really I don't know. والحقيقة الوضع احنا زي ما قلنا احنا مصرين